What's up, ML Pros? Today we are going to look into how can you tell whether a sentence is from the book, the Bible, or Harry Potter. It's not always easy, as we will find out, but basically this higher group of problem is called sentence classification, text classification. Is really hyped with all the new NLP models coming. On a very high level, this is going to look like this. We're going to take the Harry Potter books, I'll link it somewhere, how to find it, and the Bible. We'll strip them for the sentences individually, roughly to the same size, right? Just take as much text as possible. We'll feed this into a so-called Huggingface module, or a transformer, really, if you know the name, effectively transforming a sentence into a very long vector of numbers, which is then ideally for PyTorch, where we will use another cool PyTorch Lightning deep learning module. So let's dive right in. You can download the books here. I don't know exactly what the copyright on Harry Potter and the Bible is probably free, but yeah. There we go. Install some dependencies. Today we are going to use sentence transformer and PyTorch Lightning. As mentioned again, the sentence transformer transfers your text into a vector, and PyTorch is then actually going to do the prediction. You could also do all of this just with Hugging Face and put some dense layers on top of it, but we are not going to do that. The reason for this is because in a tutorial like this, it's going to be quite expensive, and you definitely want one or more GPUs for this. Really, it's quite expensive, but it's a nice example if you have the power for it. Not very difficult. So good. This is the model we are going to look at. So what is Hugging Face? I kind of missed it on my list of the most important machine learning tools, but it really should be on there. It's the state-of-the-art Python package, not just Python, for any language by now, module to convert or to work with natural language data and deep learning. So if you want to use these two, Hugging Face got you covered. They have millions of models here, probably millions, but thousands of models for various languages and use cases, and they are pre-trained on so much data that you don't want to start from scratch, no matter how much data you have. So the model we are going to use today is a very popular one, actually here, 4 million downloads. It's called Sentence Transformer, and it has been trained in multiple languages. I just wanted to get you all started with multiple languages as soon as possible. And really what it does is, it's indicated here somewhere, it takes a sentence and then it encodes it. This encoding process, as already described, you will often hear encoding, embedding. These are all kind of the same terms. They just mean turning, very simply speaking, turning an object or a string into numbers. So you, instead of having a sentence with 17 words, you then have a vector with 768 values. That's really what encoding or embedding means in the context of this tutorial. This is how you load the sentence transformer. It's straight simple, and you could now embed model here dot encode, and you could encode a sentence, which we're going to do in just a bit. Let's load the data. We got once our Harry Potter books, we got once the Bible. They are two of the all-time classic fantasy books, I guess. I probably annoyed someone with that. Anyway, so we got here two folders. You can pretty much take all the text you want. I found these two to be pretty popular. If we go effectively into these folders, we see here it's like 5 files, and here it's like one file. Again, you saw the structure. It's like just text and then paragraphs and some dots here and there, which are going to tell us where sentence ends and where one starts. We're gonna iterate over all these files. That's basically this chunk of code. Once we've done this, we do a pandas series. For those that don't know, pandas is really just the Excel for Python, and pandas.series is really just creating a column, right? If you think about one of these Excel spreadsheets, you get like a column. And we then also need a label. So for machine learning, you always have ideally you have for supervised learning, you have data and you have some label for it. Of course, we're gonna give the label here in. We see that we have two classes. Once we have the Bible and we once have Harry Potter. How do we call this function? We give it the folder A. So the folder A here is Harry, the other one is Bible. We give it the true label. So since we have binary classification, we can just do 0, 1 really. And to just walk through the function again, here first print statement, the book we randomly picked. We're anyway gonna shuffle this later, so don't worry. Here just the last two sentences, and yeah, here it is, our final output to some extent. We got sentences in one column and we got the label true here for Harry Potter. For the Bible we really do the exactly same thing. Here we call the function again, this time with the other label because we want to tell the one from the other. Anyway, sentence, label false, so this is our dataset, bam. Let's merge the dataset, bam. So concatenate really just appends these two datasets against each other. I mean, like, just if you have two Excel spreadsheets, they're like merged like this, so that you just then totally have 101,000 rows. And we can actually plot this here shortly. And we see here it's just a lot of truths and a lot of false, both appended to each other. Next thing, we have to clean the data. We have here like various signs that give it away. For the Bible it's extremely obvious with these like numbers, so we'll remove them. And yeah, these redundant spaces. How does this look? I just used some like cheap apply function, and apply function is a function that goes over, I mean in this example it goes over all the rows, and it really just takes here the sentence element, so that is this one, and it applies this Python construct to it, which you probably know fairly well. Once we're replacing \n, that's the line break, so when you go to a new line we will replace the double dots and we're going to cast it to lower. This regex, if you're not familiar with regex is an additional programming, or no, it's not a programming language, but it's a little helper tool that helps you to transform text into other things. And the backslash D is like a special command to replace numbers with here empty strings, and we're going to do that. This is really just going to convert our example into something like this. Long talk, short meaning, or something like this. How the actual end product looks is like this. Harry Potter, I, Dudley, demented the hottest day of the summer, blah blah blah. So it's all clean and it's all like lowercase and looks somewhat similar to the Bible. And there went out another horse that was red and power was given to him. That, yeah, it's complicated to read the Bible, but really these two look now the same, so we can get started with the actual machine learning. One more thing, balancing the data. So you see, when you are in a classification task and you have more samples from one class than from the other, this is not good for deep learning or most machine learning algorithms. You can to some extent deal with it, but it's just way easier for the tutorial if we just cut the amount of Bible sentences down to the amount of Harry Potter sentences, and we'll get a much better estimate down below. So this little statement really just does that, and once we're through with it, we shuffle again and we see we have now the same amount of samples from both classes. Now, finally, machine learning happening. I know data engineering is a huge part of machine learning, and I don't know, also in real life you will find yourself doing it more than actual machine learning, sad to say for people that hoped otherwise, I guess. How does this model now work? If you remember, in the beginning I told you that the process of encoding or embedding really is taking this model and turning sentences into vectors. This particular implementation from Huggingface or from the sentence transformer does so by taking a list of sentences and then converting it. It will be a matrix of 2 times 768, as you can see here. Effectively, you have for the first sentence, I am a sentence, you have the first 768 that one vector, and for the another sentence you have the other 768 values. So really, again, to repeat this, because I don't know, it can be really complicated if you think a bit too hard about it, but really it's just the process. You take one sentence, you converted it into 768 numbers, which is a vector. You convert 2 sentences, you convert 2 sentences into vectors of 768 numbers, and then you throw these two together and you get a matrix, and this is your training data. If you do this now for a lot of data, as I did here, as you see, it took like 1 hour and 40 minutes. I'm on a particularly slow VM here, so could be sped up with GPUs for sure, but really what you'll end up with is a lot of numbers, 53k something, which is these 2 numbers added. Really great. We've cleaned the data, we've loaded the data, we've looked into how to embed a sentence, which looks again like a huge matrix. we can now train a model using our favorite machine learning or deep learning framework, PyTorch Lightning, and it's gonna be really easy. As always, the first thing you should be doing is defining a dataset class. The dataset class is implementation from PyTorch, not directly PyTorch Lightning, and it has handy methods. Basically, you need to define these three things: get item, len, and init. In the init function, you initialize your data or some variables. You don't actually need to do that. And in the get item function, you get an index, and you need to return some item and the label which belongs to it. The length function really just has to return the entire length of your dataset, such that PyTorch Lightning can take this class or this inherited class and do its magic with it, and being the fastest deep learning framework on the market. So how do we do this in total? We have a total length. We want three things. We want to train, a test, and a validation set. This looks like a bit of complicated, I don't know, splitting logic, but really we take the first 80%. Remember, you can only do this if your data is shuffled. We take the first 80% as our training data because that's somewhat common. Then we take the next 10% as our training data and the last 10% as our validation data. So if you see it here, we really just take the encoding, do a bit of Python splitting, and we'll end up with these three data sets. You have to give here a string into when you initialize this data set, so such that we know which one you want to call for. How does this look in practice? We start our data set, so the default argument is train, so we'll get 80% of the data. If you now call the get item function on the first element, if you see here, I converted it to torch, which is necessary if you want to throw it into PyTorch Lightning. And if you get now the first item, you get this vector again, this embedded sentence. So this is now the first sentence of Harry Potter, let's say. It's shuffled, so it's not, but hey. And then you have a label. So one stands for, which one was one? One was for actually the Bible. Okay, so it was some random sentence from the Bible. Here, one is true, one is true. Oh no, it's actually Harry Potter. Okay, one is Harry Potter, 0 is the Bible. Just remember if I forget it again. So the model definition, how do you define a model in PyTorch Lightning? It's really simple, and if you want to know a lot more about this, I have an entire tutorial about PyTorch Lightning. You probably all have seen by now. Anyway, you inherit from the Lightning module, which we imported somewhere at the top. You have to define not all of these functions. I think in the only functions you really need to define is init, forward, and train data loader, and the rest is kind of up to you, but they have a lot of handy methods which just make life so much easier, and the optimizer is also required. How do you define our model? So we're gonna do a 2 times dense layer. So I don't know, dense layer, do we have an image here? So it's a random Google maybe. Find something. So this is dense layer. If you have 2 of them, it's really just this. And so here's an input. This is now 768. Then there's dense layer. There's another dense layer, and then, as we can see here we got a sigmoid. We actually just need one output, which has to be a number between 0 and 1, which we'll interpret as the probability. 0 being hey, it's guaranteed the Bible, and 1 it's guaranteed Harry Potter. And you just need one output for a binary classification. We'll initialize the learning rate to something, the batch rate to something. You can do around with these numbers. I really didn't, because we're actually going to use the auto learning rate learner from PyTorch Lightning, which is the coolest fucking thing, and I fucking love it. So next thing you need to define is a forward function. As you can see, it's really easy. You call the first layer here, you get an X out. The mathematics behind the scenes are done by Torch or PyTorch, and then you call the second layer, you get again an X, then you call the output, which is the sigmoid, and you have to reshape because it's just one output. So forget this reshape, it's just such that it doesn't break. Next thing, we initialize an optimizer. We got the Adam optimizer. If you here add the self.learning rate, you can actually use the self-learning rate learner. So the tool of PyTorch Lightning that learns the learning rate, and you just have to do it like this. Really not much thought about this. You could use way cooler optimizers than this one, and yeah, feel free to experiment with everything that's on the market. Data loader, we got the train data loader and we got the validation data loader. As remember, one gets 80% of the data, the other one gets 10% of the data. Really, a data loader has to get as an input a data set, which we've defined above. You can then define as well a batch size and a shuffle and all the strange for loops that you normally would have to do if you remember back in the times. They're not anymore here. It's clean and nice code. You don't have to shuffle the validation data because, yeah, why would you? Now you have to define validation step and train step. So this defines exactly how you want to calculate the loss when you get a training example and throw it through the forward function so that the model actually kind of learns, right? Yeah. You can define the loss here. Just be sure to use some function from PyTorch Lightning or some of these function. You cannot like differentiate every function, so use this module. Or some concatenation of it is also okay. You log these losses. We'll see below why we want to do that. Then training step, really the same thing, and then here I made just one nice function for us where we can just give in a sentence. We then automatically encode this sentence, we send it through the forward function, and then we get a return value. So this will be our function where we can just send in a sentence and then we get the response from the model, whether it's Harry Potter or whether it's from the almighty Bible. Finally, the juicy part, training. Seed everything just to make everything reproducible. You know, these random numbers inside NumPy, PyTorch and so on, they just kind of wiggle with the results. So seed everything and you should be good to go. I mean, actually no, it's still random, but it's a bit less random. So hey, yay. Early stopping. So early stopping is a method of kind of stopping your training process at a point where your validation loss does not any further improve, and it's kind of to avoid overfitting. Yeah, to do this with PyTorch Lightning, it's extremely easy. So you just monitor a variable, which is exactly why we log here the validation loss. It used to be a bit different back in the days, but hey, cool. We say a min delta and we say a patient, so it will, when the difference between one epoch and the next one is smaller than this one, then it will stop the execution, but it will wait for 5 epochs until it has decided that the loss will not decrease any further, if that made any sense. Now let's cast our model to a device. You can either use the CPU as I did for a tutorial. I think it's just easier, or you can use a GPU. You maybe have to throw some 2 CUDA functions everywhere around the dataset, but it should have that in like 5 minutes. Then you can actually train your model, and this is the really cool stuff. So let's say max 100 epochs, really not useful. Auto learning rate finder, auto scale batches false because it's a bit strange. The progress bar, we want to, I think, increase it every 10 batches, and the callback is on the early stopping so that the model knows when we want to stop. We now hit first tune, so trainer.tune, and if you kind of go through here, you see what it does. It finds the best learning rate. You don't really see anything happening here in the logs, but if you have larger testing size, you will actually see something happening, and it will then determine that the best learning rate here is 0.0019. In a real life scenario, you just kind of want to hit that number, here, and then kind of tune a little bit, like from a human perspective, to the optimal rate, because it's not like, I mean, it's magic, it's great, I love it, but it's not perfect, you know. It's still a huge help in your life, so that's also why I kind of include it in my tutorial. Now the real training starts. So if we hit trainer.fit, it will apply this learned learning rate and all these other things, and will go in epochs through all the training data and all these loops that you know from more normal deep learning. It will all do these things automatically, and you can see here validating blah blah blah, the validation loss and so on. It's actually not logged here, but we see here the last 5 records, best score 0.044, and we stop here training. Other things we can see here is the amount of parameters that we had per layer, and also our total estimated model parameter size, so just 3 megabytes. It's all good. Just to repeat, we took some sentences right from the Bible and from Harry Potter. we cleaned that data a little bit such that they look the same. We took those sentences, threw them into a Huggingface sentence transformer model, got out like a matrix where each column represents a sentence and effectively is a 768 vector. We took that data, threw it through a deep learning model, and it learned to minimize now the loss of distinguishing these two sentence types or document types or text types from each other. Now when we call this model with the function above, just work for me, it will take a sentence and it will send it through this trained model. What we have to do for this, we have to convert the sentence from NumPy into Torch and forward it. First we have to embed it actually, right? Let's do this now and look at the results, which are kind of interesting. So first one, Harry is weird. We remember 1 being Harry Potter and 0 being the Bible. So true being 1 and false being 0. So Harry is weird, no surprise here. The model is absolutely certain that this sentence is not from the Bible. God is weird, and we see the absolute opposite of the result. Now, Lord of the Rings, you shall not pass. It's kind of interesting to me that it puts it right into the middle without ever having seen a Lord of the Ring data. I mean, it's purely luck, but I find it's lovely. Like and subscribe, guys, which seems to be from Harry Potter. So I'm more of a Harry Potter guy, as this medal tells me, and you guys probably know what you have to do now. Yeah. God is living in London with his family and learns magic. I thought this is a tricky one, but apparently it's a lot closer to Harry Potter. Here's actually a false positive. I took this from the Bible. Nevertheless, whereto we have already attained. Let us walk by the same rule. Let us mind the same thing. It also kind of sounds a bit like a fancy book, so yeah, it's a bit of modern Bible translation, I guess. And you also see it's, even though it's from the Bible, you get a 99% chance that it is from Harry Potter. It's not always right, but you really have to look for a sentence where it's not good. Let's do now a classical test evaluation on our test set. If you remember, again, we had the first 80% of the data being our training set, 10% for validation, so effectively for the early stopping, and now we have 10% where we can just play around and data that it hasn't seen so far. To do this, we again just hear some boilerplate code. It's not very nice. I just made it such that it works fast and easy for us. We convert our test data into the results, and basically, this is a list compression. We go over the test data. We convert all of these to just work for me with the model, and throw this all into a list. Now let's look at the first 5 examples, just to look at how it works, how good it works, and what it does really. Monday evening, he felt suddenly light and happy. Sounds very Harry Potter, right? Well done. Label also true. Verily, I said unto you, that this generation shall not pass till all these things be done. And we see that sounds very Bible-ish and not that easy to read for a non-native speaker like me. And it's again right, or like wrong meaning Bible. Marvola blah blah blah. We see here. Do we have something interesting? Not that much here. They're all very clear examples, and none of them is actually wrongly classified. Last thing, I always like to include some sklearn into my examples, just to give you all these helpful little functions that you can play around with. Now, how can you use the classification report? What does it? It gives you like a little overview like this one, where we can see that we're really good. So on 99% of all examples, we are just pretty much perfect, both recall, precision, and F1 score. We have here on our test set a support of each 2600 blah 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 samples, which is 10% of the data that we sampled. If you remember, quite above we downsampled the amount of Bible sentences to 26, and now we have 10% of that, which is the test set. It's the support really, which just means we're great. So we always kind of get what's in the Bible, and we always kind of get what's in Harry Potter, and this model successfully learned to transfer and distinguish between Harry Potter and Bible sentences. Just a little reminder, how can you use this in practice? Again, if you like get mails and you don't know to which department to redirect them, you could use a model such as this one. If you, for example, wanted to classify documents, you could just concatenate several of these embeddings and try whether it works. If you get emails for different support tickets and various other very cool applications come to mind, and you really can switch all these encoder models here. You have a pretty much infinite amount of models on Huggingface, so I highly recommend it. Most of them will be good for it, from GPT-2 to German, French, Chinese, and whatever language you speak or want to work for. And yeah, I wish you a lot of fun playing around with Huggingface, this model, and I hope you enjoyed this video. This was it with me for this week, and please like and subscribe if you enjoyed this video. There will be surely more deep learning if you do so.